The Earth has been hurtling toward Jupiter for the past 242 days, and now we're about to make impact. We're so close to the giant planet that it's the only thing filling our entire sky. Ground temperatures on Earth are rising uncontrollably. Our atmosphere is igniting into flames. The scientific community is scrambling for answers. What will happen when these two planets collide? Is there any chance we could survive? And how would this collision transform Jupiter forever? Before we send Earth on a collision course with Jupiter, let's understand exactly what we're dealing with. Jupiter isn't just big, it's incomprehensibly massive. Jupiter is the largest planet in our solar system by far. You could fit approximately 1,300 Earths inside Jupiter's volume. Imagine taking our entire planet and multiplying it by 1,300. That's how much bigger Jupiter is. Jupiter has a mass that's 318 times greater than Earth's mass. It's so massive that it actually affects the orbits of all the other planets in our solar system. Some scientists even argue that Jupiter is almost massive enough to be considered a failed star. It just didn't quite accumulate enough mass to ignite nuclear fusion in its core. But here's what makes Jupiter truly unique. It's a gas giant, meaning it has no solid surface. Unlike Earth, which has a rocky crust you can stand on, Jupiter is made almost entirely of hydrogen and helium gas. If you tried to land on Jupiter, you'd just keep falling deeper and deeper into increasingly dense layers of gas until the pressure crushed you. Jupiter's atmosphere features the famous Great Red Spot, a storm system that's been raging for at least 300 years and is large enough to swallow 3 Earths. The winds in Jupiter's atmosphere can reach speeds of 640 kilometers per hour. This is what Earth is about to collide with, a planet so large it could contain over 1,000 Earths, with no solid surface, extreme atmospheric pressure, and storms larger than our entire world. One way that scientists could find answers about what would happen to Earth is by looking into Jupiter's past, because this wouldn't actually be the first time that Jupiter has collided with another planet. Nearly 4.5 billion years ago, when our solar system was still young and chaotic, Jupiter was involved in a violent collision with another planet. And not just any planet. This was a massive world approximately 10 times the mass of Earth. In that ancient collision, the impact completely transformed Jupiter's internal structure and core composition. But what happened to the other planet? It was utterly destroyed, absorbed into Jupiter's massive bulk. And what does that tell us about our own planet's chances of surviving a crash into this gas giant? Spoiler alert, they're not good. To fully understand what's about to happen to Earth, let's travel back in time to 4.5 billion years ago, when Jupiter was just a young planet trying to find its place in the newly formed solar system. Back in the early days of our solar system, Jupiter was a terrifying gravitational force that fundamentally reshaped everything around it. During its formation period, Jupiter's gravitational pull became approximately 30 times more powerful in just a fraction of a million years. For cosmic timescales, that's incredibly fast, almost instantaneous. As Jupiter rapidly accumulated gas and grew to enormous size, its gravity grew exponentially stronger. This sudden increase in gravitational power had catastrophic consequences for the surrounding region of space. The powerful gravity destabilized the orbits of nearby infant planets, small rocky worlds that were still forming and hadn't yet settled into stable orbits around the Sun. These destabilized planets began to spiral inward, their orbits decaying as Jupiter's gravity pulled at them. Some were flung outward into the outer solar system or ejected entirely from the solar system. Others weren't so lucky, they crashed directly into Jupiter itself. It's believed that multiple planetary collisions occurred during this chaotic period, but one collision in particular stands out, the collision with a planet 10 times Earth's mass that fundamentally changed Jupiter's structure. Scientists have studied Jupiter's internal structure using data from the Juno spacecraft and have pieced together what must have happened during that ancient collision. The planet that hit Jupiter was approximately 10 times the mass of Earth. It was primarily composed of rock and metal with a silicate and ice core, similar to Earth's composition but much larger. This was a substantial world, not just a small asteroid or comet. The impact was violent and incredibly fast. The planet struck Jupiter at a speed of approximately 46 kilometers per second. That's about 130 times faster than a bullet. At that speed, the kinetic energy released would have been unimaginable. Despite the enormous energy of the impact, Jupiter only lost a small amount of mass from the collision. Some of its outer atmospheric layers were blasted away into space, but Jupiter's immense gravity held onto most of its material. Jupiter was simply too massive to be significantly damaged by something only 10 times Earth's mass. But while Jupiter survived mostly intact, its original core was completely changed by the collision. Before the impact, Jupiter had a dense, compact central core made of heavy elements like rock, metal, and ice. The rest of the planet's interior was composed of layers of hydrogen and helium gas. After the impact, something remarkable happened. The impacting planet's silicate and ice core merged with Jupiter's core, but the energy of the collision was so great that it disrupted Jupiter's internal structure. Jupiter's core became diluted and spread out. The heavy elements that were previously concentrated in a compact core dispersed and mixed with the outer layers of hydrogen and helium. Today, instead of having a dense, compact core, Jupiter has a diluted core where heavy elements are mixed throughout a much larger region of the planet's interior. This discovery was only recently confirmed by the Juno mission. While this collision was a defining moment in Jupiter's evolution, fundamentally changing its internal structure, it meant the absolute end for the other planet. The impacting world was completely destroyed, its material absorbed into Jupiter. Nothing recognizable remained. So what are the odds that Earth's fate would be any different? Let's find out. The Earth normally orbits around the Sun at an average velocity of 29.78 kilometers per second. That's about 107,000 kilometers per hour. Incredibly fast, though we don't feel it because we're moving along with the planet. Now imagine something catastrophic happens. Maybe a close encounter with a rogue planet or massive asteroid disrupts Earth's orbit. Or perhaps some advanced alien technology deliberately pulls us out of our solar orbit. Whatever the cause, Earth suddenly leaves its stable orbit around the Sun and begins heading straight toward Jupiter. At Earth's normal orbital speed, if we were to leave our orbit and head directly toward Jupiter, it would take approximately 242 days to reach the gas giant. That's about 8 months of traveling through space toward our doom. Let's experience this journey day by day and see what happens. Throughout our journey toward Jupiter, the massive planet would dominate our sky more and more with each passing day. At first, Jupiter would appear as just a bright point of light, brighter than any star, but still just a point. But it would be growing noticeably brighter every single day, hour by hour. You could watch it expand in the sky if you were patient enough. By day 6 of our journey, Jupiter would appear as bright as our moon does normally. It would shine brilliantly in our sky, casting Jupiter light across Earth's surface at night. People would start to panic as this impossibly bright object dominated the heavens. As we continued our journey, we'd also notice something troubling. Our daylight would start becoming dimmer. The sun would appear smaller and smaller as we moved away from it and closer to Jupiter. We'd be leaving behind the relatively warm inner solar system and heading into the colder outer regions. By the time we reached Mars's orbital distance, about halfway to Jupiter, we'd only be receiving about 50% of our normal sunlight. The days would be noticeably dimmer, as if we were constantly experiencing an eclipse or heavy overcast skies. Luckily for us, Earth's atmosphere would act as a buffer against the cold, at least initially. Our thick atmosphere retains heat remarkably well, which is why Earth stays warm despite being in the cold vacuum of space. So we wouldn't immediately freeze when we move farther from the sun. But that protection would only last for a while. Eventually, without the sun's constant warmth, Earth would begin cooling down rapidly. The oceans would start to freeze. The atmosphere would begin to condense and fall as snow. Within weeks, Earth would become an ice ball hurtling through space. To put it in perspective, Mars has an average surface temperature of minus 63 degrees Celsius. That's basically what we'd have to look forward to as we pass through Mars's orbital region. You'd definitely need to invest in some heavy-duty winter gear. We're talking Antarctic research station level of cold protection. Except everywhere, all the time. The good news is we wouldn't have to endure the cold for too long. The bad news is why we wouldn't have to endure it. As we continued our journey toward Jupiter, we'd pass through the asteroid belt, the region of space between Mars and Jupiter filled with rocky debris left over from the solar system's formation. This part of the journey would actually be quite beautiful. We'd get to see spectacular meteor showers lighting up the sky as small asteroids and dust particles entered Earth's atmosphere and burned up. The night sky would be filled with shooting stars, dozens, maybe hundreds visible at once, but we'd also be at serious risk of colliding with some of the larger asteroids. The asteroid belt contains millions of rocky objects, some of them hundreds of kilometers across. At the speeds we'd be traveling, even a relatively small asteroid impact could be catastrophic. A collision with an asteroid just a few kilometers in diameter could trigger extinction-level events, mass extinctions, global firestorms, impact winters lasting years, and we'd be threading our way through a field of millions of these objects. So let's hope Earth's trajectory takes us through a relatively clear path. We'd want to move through the asteroid belt as quickly as possible to minimize the risk. After 242 days of traveling through our solar system, through cold darkness and asteroid fields, we would finally reach our destination, or perhaps reach our doom would be more accurate. As Earth approaches Jupiter and crosses into the giant planet's gravitational influence, we'd begin to accelerate. Jupiter's immense gravity would pull us in faster and faster. Our velocity could increase dramatically until it reached approximately 60 kilometers per second. That's about 216,000 kilometers per hour, or roughly 250 times faster than a commercial airplane flies. At that speed, you'd want to hold on tight to something, not that it would help much. And here's another problem we'd have to deal with. Jupiter has 79 confirmed moons orbiting it. Some are tiny, just a few kilometers across, but 4 of them, Io, Europa, Ganymede, and Callisto, are massive worlds, some larger than our moon, one even larger than the planet Mercury. As Earth is pulled in closer to Jupiter, there's a serious risk that we could collide with one or more of these moons. A collision with Ganymede, Jupiter's largest moon, would be like 2 planets smashing into each other. Both worlds would be devastated. Let's assume we somehow thread the needle and avoid all 79 moons. Things are still about to get much, much worse. As Earth crashes into Jupiter's upper atmosphere, the collision would be absolutely catastrophic. Both planets' atmospheres would be compressed violently by the impact. When you compress gas rapidly, it heats up dramatically. This is basic thermodynamics. The temperature would increase so rapidly and to such extreme levels that it would essentially set the air on fire. Earth's atmosphere would ignite in a globe-spanning fireball. Every living thing on the surface would be incinerated instantly. The oceans would flash into steam. The very rocks of Earth's crust would begin to melt and vaporize. But it gets worse. As Earth plunges deeper into Jupiter, we'd encounter increasingly dense layers of gas. The atmospheric pressure would increase exponentially with depth. The pressure would become so intense that it would compress and crush anything that remained of Earth. The temperatures would also skyrocket. Deep in Jupiter's interior, temperatures exceed 5,000 degrees Celsius, hotter than the surface of the sun. Earth would be subjected to these infernal conditions as we plunged deeper. You might think that eventually Earth would reach Jupiter's core, and maybe, just maybe, some fragment of our planet could survive there. But that won't happen. Our planet is simply too small and would burn up completely in Jupiter's atmosphere, long before reaching anything resembling a core. Earth would be vaporized, melted, and dispersed throughout Jupiter's outer and middle atmospheric layers. Everything that once was Earth, the rocks, the metals, the water, the atmosphere, every living thing, every human creation, would be reduced to atoms and molecules mixed into Jupiter's swirling gases. But while Earth would be completely destroyed, this would actually have a significant impact on Jupiter itself. Earth's remains would completely mix into Jupiter's atmosphere, adding new elements and compounds to the gas giant's composition. Jupiter's atmosphere would gain a significant amount of heavier elements, silicon, iron, oxygen, carbon, from Earth's vaporized material. These elements would gradually mix throughout Jupiter's vast volume, subtly changing the planet's composition. The Great Red Spot might even temporarily change color or behavior as it absorbed some of Earth's material, but within a few years or decades, Jupiter would return to equilibrium, and there would be no visible evidence that Earth had ever existed. So if you ever notice our planet going off course and heading toward Jupiter, you definitely want to jump ship along the way. Your best bet would be to abandon Earth right as we pass Mars's orbit, about halfway through the journey. Mars might not be the most hospitable planet, but it's better than being vaporized in Jupiter's atmosphere. You'd have a chance to survive and potentially establish a colony on the red planet, while watching Earth continue its doomed journey toward the gas giant. Of course, watching your home world be destroyed would be traumatic, but at least you'd be alive to remember it. The good news is that Earth's orbit is remarkably stable, and there's nothing in our solar system capable of knocking us out of orbit toward Jupiter. We'd need a truly catastrophic event, like a close pass by a rogue planet or a direct intervention by advanced aliens, to send us on such a collision course. So you can rest easy knowing that Earth won't be swallowed by Jupiter anytime soon. We're safe in our cozy orbit around the Sun, and Jupiter will remain where it is, a beautiful giant in our night sky rather than an instrument of our destruction. If you enjoyed this catastrophic journey through our solar system, subscribe for more explorations of cosmic disasters and the extreme physics of planetary collisions. Stay curious and appreciate the stable orbit we have.